What's up, guys? Your video for you from me is problem 24 out of some of the notes we did the last couple of days. Popular problem came up twice, so you might see some redundancy in the work you got here. Step one, go to Desmos, graph this thing, and then let Desmos handle the function notation, the function division. It's important, or more important, to just look at the pictures and know what you are supposed to be gathering as we see there. Some of the things that come up with this is that h of x is a polynomial. Specifically, it's called a quadratic, and that means all real numbers are possible for its domain. And if that's the case, then we have maybe some restrictions we have to be concerned with that actually break in the relationship of how those numbers are used, like zeros. Zeros are going to be a problem. Q of x is a function that has a square root. Square roots, they really don't allow for anything negative. Also in the q of x function is the fact that it's a fraction. 1 over 0 is a problem. So we are able to restrict the domain of q to everything that is positive, not 0, definitely no negatives. You can see that when you put q of x divided by h of x together, and you get this function that shows an asymptote at 3, and it also shows kind of hidden, kind of not there, another asymptote at 0. Well, that means then that the domain of this function q divided by x is all real positive numbers, not 0, not 3. Hopefully it comes in clear enough as you're watching the video, or you can zoom in. You can see how we would write that in interval notation. Using parentheses because you do not actually have access to 0 or access to 3 or access to infinity, so we use parentheses, not brackets. Next problem up is q of h of x. Graphing it, what pops up are two asymptotes, a positive 3 and negative 3. And technically the graph doesn't exist between there because, well, that would make the denominator be less than 0. It'd cause a problem with our calculation. X squared minus 9 would be negative, and you can't square a negative, and so therefore it doesn't exist. Anyway, point being, everything outside of those values, pay no attention to the solid line, but everything outside of those values would be the domain. To write it in interval notation, still using parentheses around the two interval sections, negative infinity to negative 3, and so on, we're able to write that domain as well. All you got to do at Desmos is do a little quick flipperoo. H of q of x, get a look at the picture, kind of mess with zooming in, zooming out, click the wrench. It can't be negative because you're talking about a square root that only allows positives, and you're furthermore asking for things to be greater than 0. It can't even be 0 because that'd be a problem in the bottom. For your information, this is called inequality notation. So I showed you interval, I showed you with words, and I showed you inequality notation. This picture, this video is brought to you by some picture a student drew of me years ago, where apparently I'm reciting only 3 numbers of pi. I know many more. Thank you for watching this video. Catch you on the next one.